All right, this is REQ 15 6.2, question number 9, worked out by request. All right, with this situation, we do have two equations. Well, excuse me, we have one equation, but we have two fractions equal to one another. Similar to what we had done with question 8, we can multiply both sides by our least common denominator and get this to be a whole value almost immediately. Between 5 as one denominator and 4 as the other, least common denominator would be 20. It's a multiple of 4 as well as a multiple of 5. Hold on, I'm adjusting. This is me holding it. So we can multiply on both sides by 20. Should be 20 over 1 technically. The 20 and the 4 reduce to give us 5, so x times 5 is 5x. Here, we would have the 5 and the 20 reduced to the 4. 4. Do be careful, you want to keep that in parentheses, otherwise you might not distribute that 4 to that whole numerator. And we are dealing with 4 times 3x plus 2 equals to 5. And use the distributive property to multiply both terms by 4. So we get 12x plus 8 equals 5x. I like to subtract by the smallest 5x, but since that's by itself, let's say, hey, let's take everything over to the 5x. In order to do that, still thinking opposite operations, we're currently adding a 12x. I will do the opposite of that to get the x's consolidated. All right, when we have a positive and a negative, we are opposite signs, so we are going to subtract and take the sign of the larger. 12 minus 5 is 7x, but the 12 being larger, we're going to keep that negative sign on that 7x. And then we have that 8 left over since this does cancel. And our final piece, to get x by itself, right now negative 7 is being multiplied by x, so the opposite operation would be division by that same constant on both sides. What you do to one side, you must do to the other. Our final answer is negative 8/7.